Wow, hello viewers, welcome back to class. Yes, you're welcome to Master Builders Online Academy. Now, if you are new in this channel, do consider subscribing to our channel and ensure you turn on the post notification bell for more exciting videos. Guys, let me blow up your mind. In this video, we have already put in place the principles that when you get access to them, you will gain mastery in solving problems under logarithms effectively. Yes. You want to see that? Just wait, relax. Don't be in haste. We will hold you by the hand and walk you through the process that are involved in solving problems effectively using some of the laws we have looked at in first video. In the first video, we looked at the laws of logarithms. In the second video, we looked at problem 1, problem 2, and problem 3. In each of those problems, we solved different problems. Now, in this lesson, we shall be looking at problems that will make us make use of law 1, law 2, and any other laws all combined. So in this case, we shall be solving problems where we will require multiple laws of logarithm to solve just one problem. Guess what? It is always easy for you to get this done. So what you will do for me now and do for yourself is to ensure that you do not skip any part of this video. Why? Because every bit of this video are principle encrypted, principle based. So if you skip any part, you may skip the principle that would have helped you gain mastery. So I advise that you watch it from beginning to the end without skipping any part of this video. And also, now that you are set to watch and to learn new concepts from this platform, do not welcome any form of distraction, because when you are distracted, you will not be able to maximize all the principles that we share in this video. And finally, if after watching this video for the first time, you are not clear with some principles as applied, please, you have the opportunity to replay the video over and over and over again. Guys, this is one of the reasons why these lessons are coming in video format. Now, if at the end of watching the video over and over again, you still have questions to ask, hey, don't hesitate. Just slide down to the comment section and make your questions known to us. We will give you answers that will satisfy your question. So if this is taking and you are super excited for us to commence this teaching, guys, let's jump into the marker board as we begin to solve these problems. Now on the board, we have question number 4. We are asked to evaluate the following without using tables. And when we started in the first lesson, I made it clear that logarithm can be given either to solve with table or to solve without the use of table. Exactly what we have on the board now is the type of logarithm where the use of table is not required. And where you don't use the table, then you use logs. Are you there? So that's to say, now that we are not using table, we are going to be using logs. And the logs are rightly before us here. So all I just need to do is to show you how these laws are used without missing words. Now, on the board, we have the very first question under this question number 4, which happens to be Roman figure 1. We are asked to find log 25 base 10 plus log 4 base 10. Now, like I said before, the first thing you watch out for is that anytime you have multiple log of numbers, check for 3 things. Number 1 is to check what sign is connecting them. Number 1, sign is plus. We have gotten that. Then number 2 is to check if they have equal base. Yes, this is base 10. This is equally base 10. That means we have the second one passed. Then the last thing we must also check for is if the log of numbers have equal coefficients. Yes, of course. The coefficient of this logarithm is 1 and the coefficient of this other guy is 1. These 3 things, when they are in place, you can use the first law of logarithms to solve these problems. You see, why I'm taking my time to solve this first problem now is that when you understand this first question, in fact, without solving question number 2, 3, and 4 for you, you can solve it. Remember, my interest is to teach you how it works. So I can teach you one problem where you can solve 100 problems, in fact, 1 million problems on your own. That's it. Then, if this is taken, then we can now pick one of the log to the base, now multiply the log of the numbers. Don't forget, addition turns to multiplication. Then if I multiply 25 by 4, I have 100. Then this becomes log 100 over base 10. Now don't forget that now that we have log 100 base 10, we have successfully reduced this composite or this complex log to one simple log. And we may not stop here because there is a way or something we can do to reduce this expression further. And what is that thing that we will do? All we simply need to do, guys, is to find out if one number is bigger than the other. And if one is bigger than the other, then we are going to divide the biggest number by the smallest number and find out if that smallest number can go into the bigger number without a remainder. Are you there? So we put down 100 and then divide 100 by 10. 100 divided by 10 is 10. And 10 divided by 10 is what? 1. That is to say, 10 times 10 is 100. And 10 times 10 is the same thing as 10 raised to the power of 2. Hence, we will have this guy as log of 10 raised to the power of 2 base 10. Automatically, this will have given us 2 log 10 base 10. And we understand that the 6th law of Logarithm, as we have on the board, says that the log of a number to the same base is 1. That means log 10 base 10 is 1. And 1 multiplied by 2 is 2. Hence, the answer to this question is 2. Guys, is this not simple? Very, very simple. I think I deserve the half of applause, right? Now, let's move on. Now, we have question number 2 on the board. We have Roman figure 2 log 28 base 2 minus log 7 base 2. Now, we have 2 logarithms here. Now, the next thing is to check for these 3 factors that must be met. One is to check what sign is connecting the numbers of logarithms that you have. What is connecting them now is minus. We already have 1. Then the next is to check if the 2 log have the same base. Of course, this is base 2. This other guy is base 2. We have gotten 2 marks. Now, left with the number 3. If the number 3 is out of the place, we cannot use the log. Now, let's find out if the number 3. So, for number 3, we'll check out for their coefficients. Now, the coefficient of the first term is 1, and the coefficient of the second term is equally 1. That means the conditions to which the first law and the second law is to be applied has been met. Now that it's been met, guys, what do? We are so happy to apply this law. Now, let's apply it. So while applying this law, we'll just pick one of the block to the base. Then, remember, subtraction turns to division. So pick the first number, which is 28, now divided by 7. And now, 28 divided by 7 would have given us 4. Automatically, this is log 4 base 2. And also, guys, 4 is bigger than 2, and 2 is inside 4. What is 4 in its simplest form or in its index form? 4 is 2 raised to the power of 2. Then we have this guy as log 2 raised to the power of 2 base 2. Now that we have this, all we simply need to do is to apply the third law of Logarithm by removing the power and making it the coefficient of the log. So we can have log of the same number. Automatically, we have this as 2 log 2 base 2. And don't forget, the log of the same number is 1. In other words, log 2 base 2 is 1. Hence, 2 multiplied by 1 is 2. This is the answer to this very question. Okay, very quickly, let's look at question number 3. Roman figure 3. Now for Roman figure 3, we have log 32 to the base of 4 plus log 2 to the base of 4. Now we have multiple log of numbers for which these numbers are connected with plus 1 pass mark, because we need to check the condition to which the first law of Logarithm must be applied. So now we have plus here, we already have a kudos, 1 pass mark. The number 2 is to check if the base are equal. Of course, this is base 4, this is equally base 4. Now we have equal base. Are you there? Then the next is to check if they have equal coefficient. Now, what happens if they don't have equal coefficient? You will see that in the next question. Alright? Just relax. Follow me step by step and you will gain massive values for this class for free. Now, the last but not the least is to check the coefficient, and we have checked. We discovered that these 3 conditions has been met. 1, sign connecting them, plus. Number 2 is if they have equal base, yes. Number 3 is if they have equal coefficient, yes. Then we can now pick one of the log to the base. Then addition turns to multiplication. We will equally multiply the numbers. This becomes 32 multiplied by 2. And now guys, 32 multiplied by 2 would have given us 64. Then I have log 64 base 4. Now, 64 is bigger than 4. So I will find a way to reduce 64 to 4. So I will simply divide 64 by 4 and find out how many times 4 will go into 64. Can we do that? Let's quickly do that. Of course, I already know it, but let's do that. Okay. So we have 64 divided by 4. 4 into 64 is 16. And 4 into 16 is 4. Then 4 into 4 is 1. That is to say, 64 is equal to 4 raised to the power of 3. We can simply replace 64 by 4 raised to the power of 3. Hope this is very, very clear. If it's not clear, replay the video, just take it back a bit and we get the clarification. Now, then we move further. I have log of 4 to the power of 3 base 4. So in order for us to have our final answer, we will simply remove the power of the number using log number 3 as we have it on the board. And removing the number, we simply have that as 3 log 4 base 4. And we know that the log of the same base is 1. And 1 multiplied by 3 is 3. Therefore, we have our final answer to be 3. This is all about question number 3. Now, the last but not the least in this session is question number 4. Now, in question number 4, we have 6 log 8 base 2 minus log 32 base 2. Is this not wonderful? It is wonderful. Now, look at it. Something wonderful is about to happen here. Now. Yes, now. What we have here, we find out that these 2 log of numbers to base 2 are separated with subtraction. 1 pass mark. The second pass mark is that they have equal base. Very correct. 2 pass mark. Remember, if 2 of the laws are fulfilled, 2 of the conditions are met, while the third condition is not met, guys, we cannot apply this law until the 3 conditions, boundary conditions, are fully met. Now, the sign connecting them is already a pass mark. The base equal pass mark. Now, let's check the coefficient. The coefficient of this guy is 6. The coefficient of this guy is 1. So, Can we apply the law? No. At this point, we cannot apply the law until we make the coefficient the same. How do we make the coefficient the same? We can simply remove this 6 and make it the power of 8. If this is done, by then we would have had this as 1 and this guy as 1. We cannot apply the laws. It's as simple as this. Otherwise, it is not possible at all. Then another way this problem can be solved. Listen carefully, because I said earlier, there are so many ways to kill a rat without actually sharing its blood. Then there are so many ways to solve mathematical problems and then still having the same result. So many ways to solve mathematical problems and yet you still arrive at the same answer. Okay? Now another person can say, no, I only want to make use of law number 2. There is no need. Let me see if I can solve this law individually. You can do that. It is equally possible. In fact, let's do that for this so that you know another way of having these problems solved without actually combining the 2 log using either law 1 or law 2. You can equally solve them individually. How do we achieve this? Now look at this. Do you know that 2 can go into 8? Yes. Do you equally know that 2 can go into 32? Yes, right? Accepted. Now, if this is accepted, what will 2 raised to that will give us 8? 2 raised to the power of 3 is 8, and 2 raised to the power of 5 is 32. So you see now we can work on that. Then, this will have given us 6 log 2 raised to the power of 3 base 2 minus log 2 raised to the power of 5 base 2. Now that we have powers, all we need to do is to bring down the powers using log 3. And to do that, we take this 3 to multiply 6. We have 3 multiplied by 6 log 2 base 2. Then minus 5 multiplied by log 2 base 2. You find out now that log 2 base 2 is log of the same base, which is 1. Same thing that we have here. Then 18 log 2 base 2 minus 5 log 2 base 2. So the log of the same base we agree is 1. The log of the same base we agree is 1. So 1 multiplied by 18 is 18 minus 1 multiplied by 5 is 5. And when we remove 5 from 18, our answer becomes 13. So even though you solve it in the conventional way, when you make use of law number 2, you will still have it as 13. But one of the beautiful things with this method I just used now is that you can be calculator independent. Yes, you can be calculator independent when you make use of this. If, for instance, I want to law number 2, like I explained earlier, I will have to have this guy as 8 raised to the power of 6. Guys, how many of you out there can actually find 8 raised to the power of 6 without punching calculator? You see? So you will need calculator to be able to get the answer to this guy. Right? That's it. So sometimes when you are solving some problems, you can actually go through the routes that will give you ease. Of course. All what are we after is just to get the answer. The correct answer. So if the correct answer is our major goal, then whether you follow the shortcuts or you follow the long method, provided that you do not manipulate your way to the answer, apply any of the available rules, you will not be criticized for doing so. So guys, at this point, if you are yet to subscribe to this channel, you are getting these values for free. What will stop you? Please subscribe to our channel and ensure you turn on the post notification bell for more exciting content. Don't forget to share this video. Let your friend get the same values you are gaining from this very platform. Love you, and I will see you in the next lesson. Thank you for watching. See you guys.